Okay, this question of August 2022. August 2022. Question 2A. Question 2A, the one that I want us to solve. The question says, TMA company produces 3 products, standard, deluxe, and luxury, in 3 of its departments, which are cutting, assembly, and finishing. The total available labor hours per week for cutting, assembly, and finishing departments are 180, 300, and 240 respectively. To produce 2 units of standard requires 240 minutes in the cutting department, have the amount of time in the assembly department and same amount of time in the finishing department as in the cutting department. To produce 1 unit of deluxe requires 60 minutes, 180 minutes and 60 minutes in cutting, assembly, and finishing departments respectively. To produce 3 units of luxury requires 180 minutes in cutting department and twice the amount of time in both assembly and finishing departments. The contribution per unit from standard, deluxe, and luxury is 6, 5, and 2 per unit respectively. So you are told to formulate the program. Now, as we said, the formulation goes like this. So we want to begin with the formulation. We want to begin with the formulation, and formulation, we said, you will say let we have 3 products. I want to use K, let K represent units of standard, produced and sold, units of standard produced and sold. B to be units of deluxe, produced and sold, produced and sold. L to be units of luxury, produced and sold. And make sure you are fast. These questions are very involving. If we are not fast, we may not make some remarkable progress. Then, objective function is to maximize Z, which is equal to the contribution margin for standard is 6, so it is 6K, plus deluxe is 5, so 5D, plus 2L. Plus 2L. Now this is subject to, we now record the requirements. And as you can see, this one has hours and minutes. In the question we saw last time, we converted the hours to minutes. Now this one, I wanted to convert the minutes to hours. Either way works. So when we look at the second paragraph in Asema, to produce 2 units of standard require 240 minutes. So 240, if you divide by 60, 240 divided by 60, those are 4 hours. And that is for 2 units. So that means 1 unit requires 2. So 2K plus, we are told, half the amount of time in the assembly. So if this is half the amount, then in the assembly, it must be 4K. The assembly, it must be 4K. Half the amount in the assembly, and same amount of time in finishing. So in finishing, same. So it is 2K. So plus. We go to the next one. To produce 1 unit of deluxe requires 60 minutes. So 60 minutes, that is 1 hour, 1D. 180 minutes, those are 3. So 3 hours, so 3D. And then 60 in cutting, that is 1D. Plus, to produce 3 units of luxury requires 180 minutes. Produce 3. So 3 is, that means those are 3 hours divided by 3, that is 1L. And twice the amount in both assembly and finishing. So if it is twice, no, sorry, this one I should divide by 3 so that I get 1. I get 1 because they are 3. Then when you are told twice the amount, you multiply this, you get 2L, and here you multiply, you get 2L. Should be less than, equal to, in the cutting department, we are told we have 180. This is cutting hours. Then this is 300. This is in assembly. And then 240. This is in finishing. That is in finishing. Obviously, we say K, D, and L is greater than or equal to 0. And this is non-negativity. So that is the first step when you are dealing with the Simplex method. That is the first step. Now the second step is called changing inequalities to equalities. Changing inequalities to equalities. So we normally say let S1 to be the slack variable. The slack variable for cutting hours. S2 to be the slack variable for assembly hours. L3 to be the slack variable for finishing hours. Then we need to come trying to see where I'll avoid this reflection. I'm not able to avoid it. Then let me bring it down here. Objective function. This objective function here, you repeat it, you isome hivi. Maximize Z, which is equals to 6K plus 5D plus 2L. Those are the contribution margins. You now bring these S's, but each one is coming in with a 0. So 0S1, 0S2 plus 0S3. Those are the contribution margins of the tracks. I hope you read the notes that I sent you. Subject to this one, 2K plus 1B plus 1L plus S1 is equal to 180. I have 4K plus 3D plus 2L plus F2 is equal to 300. It's equals to 300. I have 2K plus 1B plus 2L plus F3 is equals to 240. Is equal to 240. So that is how you change from these inequalities to these equations. Now from there, what I'm drawing is called initial simplex table. Initial simplex table. And the initial simplex table, it has the first column which is called C. Another one is called basis. It's called basis. Then those other columns are these values that you can see here. These ones. So I'm going to have a space for K, a space for D, a space for L, a space for S1, a space for S2, a space for S3, another space we call BI. So this will be K, this will be D, this is L, this is S1, S2, S3, this is BI. Then we normally leave a space there for something called ratio. And then here to start, we bring S1, S2, S3, the slants. Then we bring CJ, ZJ, and DJ. So once you get there, type finished or type there or type the word yes. Type the word yes when you have gone to that point so that we proceed together. And I told you to be fast. C1, Ibrahim. So I need 3 more people. And the others we're waiting for you. Okay. 3 others, I think they will be getting me ahead. Okay. So we are through. Now, here in the first column here, we normally record the contribution margins of the items here. So the contribution margins are these ones, 0, 0, 0. So here we put 0, and here 0, and here 0. Then, in these values, in these cells here, we record these coefficients here, 2, 1, 1, 1, that way. So for K, it is 2, D, it is 1, L, it is 1, S1, 1, we don't have S2 there, we don't have S3 there, but the total is 180. Kuja kwa hii ingine, K is 4, D is 3, huyu mwingine is 2, we don't have S1, we have S2, 1, S3 is not there, and then we have 300. Then we have 2 here, we have 1, we have 2, this is 0, this is 0, this is 1, and this is 240. 240. That is 240. I hope you're able to see that. CJ, we record these values in the objective function. So 6, 5, 2, 0, 0, 0, 0. ZJ, the initial table is always zeros. because it is these zeros multiplied by this. So here we always record zeros, but in the next step, I will show you how we are getting those zeros. Then this dj here, dj is equal to cj minus zj, cj minus zj. So this will be 6, this is 5, this is 2, 0, 0, 0, 0. So after you have done that, you identify the table, the DJ that is highest, that is positive, the highest positive. So this is the highest positive. So you mark it that way. And where we have found it, this column is called key column. That column is called key column, where you have found it. Key column. Then this value here, or this item here, at the title of that, here, is called incoming variable. Incoming variable. Incoming variable. From there, you got to get the ratio. And the ratio is obtained by taking this value, you divide by the values in the key column. So it will be 180, you divide by 2, that is 90. This other one will be 300, you divide by 4, that is 75. This other one is 240. You divide by 2, which is 120. 120. After you have done that, you now select the smallest here of those ratios. So the smallest is this one. That is the smallest. So, where you have found the smallest, this one is called key row. That one is called key row. The item which is at the intersection of the key row and the key column, this one here, is called key element. Is called key element. It's called key element. Then this item which is at the intersection, not at the intersection, which is at the title of the key row, this one is called the outgoing variable. The outgoing variable. It's called the outgoing variable. When you get to know that, you now proceed to create what we call the second simplex table. We create what we call the second simplex table. And I believe that you have finished to write here. I want to have this space so that I use it. Kama hujamaliza, let me draw here. But sasa tutaandika title. So the title of what I'm drawing here, andika second simplex table. Second simplex table, so that Miss Rab, and you have not finished writing. Second simplex table. So the simplex table is drawn in the same design like the other one. Okay. So this is column C. Here we have basis. We have basis. And look here, this is how we create this one. Now, this one, I have called it, or first of all, this S1. You can see it not tagged, so it remains S1. This S2, you see it has been circled, and we have called it outgoing. It is going to be replaced by what we call incoming, this K. So we are going to have K here. And then we have S3, which has not been touched. Then we have CJ, ZJ, and DJ. That way. After you do that, we record the contribution margins. For S1, it is 0. K, the contribution margin, as you can remember in the function there, it was 6. S3, it is 0. And the others do not have. So I create now the space for K, the space for D, the space for S, S1, S2, S3, PI, and the ratio. So this is K, this is D, this is L, this is S1, S2, S3, and then BI. Then in case there will be need, this will be my ratio.
Question, Mwalimu.
Yes.
How comes we retain the S and it replaced the S2? How comes we retained the K up there after the word basis?
Yes, the columns do not change. Okay. The columns, they are part of what we call the structure. They don't change. What changes are these spaces. These ones keep on changing. That's fine.
Yes, it's fine.
Yeah. And in any case, these S's, they were not part of the original formulation. If you remember what we had in formulation, the S's were not there. So we should get away of removing them. Again, also to explain it that way. They were not part of the original. So if they were not part of the original, they must finally go home or go where they came from. But not all of them will go. I believe that we are finished. So what you do next from there, you now come here and take this key element, and you divide everything here by that key element. So I will say 4 divided by 4 is 1. You record it here. It's 1. 3 divided by 4 is 0.75. 2 divided by 4 is 0.5. 0 divided by 4 is 0. 1 divided by 4 is 0.25. 0 divided by 4 is 0. 300 divided by 4 is 75. Is 75. Now below the table, below that table, we will require to do some workings. We will require to do some workings. So that now, to substitute this value of S1 and S3. There is a formula that is in your notes. So the formula, I'm going to write it this way. It is odd row S1 value I minus odd row S1 value I minus new row value I multiply by balancing figure multiplied by balancing figure. It is equal to new row S2 value. Sorry, not S2, it is S1. We are looking for S1. So that is the formula. So what I do is this. You come to the old row, this one, this S1 here. You record those values. So there is 2, there is 1, there is another 1, there is another 1, there is a 0, there is a 0, and there is 180. Then I say minus. And I say minus. Minus the new row value. New row needs to one new table. This one. So we record them. 1, 0.75, 0.5, 0, 0.25, 0, and then 75. Then we say times. We say times the balancing figure. So the balancing figure is the value at the intersection of the key column and the odd row that you are dealing with. This value at the intersection of the odd row that you are dealing with and the key column, which is 2. So unaweka 2 hapa kila mahali hivi. Namna hii, then unasema equals. Then from there, you take your calculator and you just key in the values as they appear. We say 2 minus 1 times 2 equals 0. 1 minus 0.75 times 2 equals negative 0.5. 1 minus 0.5 times 2 is 0. 1 minus 0 times 2 is 1. 0 minus 0.25 times 2 is negative 0.5. 0 minus 0 times 2 is 0. 1/8 minus 75 times 2 is 30. Although for the purposes of this question, we were only required to draw the initial simplex table. Hii maneno mengine tunafanya, I'm only doing them because you can be told to do, but this question had not said we do. So those values we quickly come and record them here. This is 0, this is negative 0.5, this is 0, this is 1, this is negative 0.5, this is 0, and this is 30. That's how we record them. From there, nimesema Jacqueline, balancing figure is the value at the intersection of the key column and the odd row that you're dealing with. So you are dealing with S1. So the value at that intersection. Is that right? Okay. Write the formula again. The formula again. So that we use it now to get the values of S3. So it will be odd row S3, up a new row S3. Odd row S3 value minus new row value times balancing figure. So sasa, the odd row S3 value, odd row is this one. So I have 2, 1, 2, 0, 0, 1, 240. Then we say minus. Minus, you bring this new row, they remain just like we had in the other working. So it's going to be 1, 0.75, 0.5, 0, 0.25, 0, and 75, then you say times. Then you say times. When you say times, the balancing figure, again, is the value at the intersection of the key column and the odd row that you are dealing with. So again, zinafanana, it is 2. It's only a coincidence zinafanana, so don't cram that all the times that were the same. So it is 2. So with that, we have 2 minus 1 times 2 is 0. 1 minus 0.75 times 2 is negative 0.5. 2 minus 0.5 times 2 is 1. This one will be 0. This is 0 minus 0.25 times 2, negative 0.5. This is 1. 240 minus 75 times 2 is 90. So those values, you quickly record them here. This is 0. This is negative 0.5. This is 1. This is 0. Negative 0.5. This is 1. And this is 90. That is 90. Then the values in CJ, they remain. So we are going to have 6, 5, 2, 0, 0, 0, 0. So those values remain. Those values remain. So let's now get the working for Z. Zj. We do the working for Zj. So this Z here, you will be taking these values in column C, you multiply with the corresponding values here as you add. So when I come for Z1, I will say 0 times 0 plus 6 times 1 plus 0 times 0. I get the answer there. Then I come to this one. Z2, which will be given as 0 times minus 0.5 plus 6 times 0.75 plus 0 times minus 0.5. When I come to Z3, it will be 0 times 0 plus 6 times 0.5 plus 0 times 1. Z4, when I go to the fourth one, it will be 0 times 1 plus 6 times 0 plus 0 times 0. Z5 is 0 times minus 0.5 plus 6 times 0.25 plus 0 times negative 0.5. And the last one, Z6. Z6 is 0 times, not actually the last one. It is 0 times 0 plus 6 times 0 plus 0 times 1. Then Z7. Z7, it is 0 times 30. 0 times 30 plus 6 times 75 plus 0 times 90. So take your calc and we start multiplying. Okay. So this one will be 6 here. This other one will be 4.5. This one will be 3. This will be 0. This one will be 1.5. This will be 0. And 75 times 6 is 450. So sasa, we say dj is equals to cj minus zj. So we start 6 minus 6 is 0. 5 minus 4.5 is 0.5. 2 minus 3 is minus 1. This is 0. This is minus 1.5. This is 0 and minus 450. So because you can see we still have a positive value here, we still have a positive value, that is not optimal. Our table is not optimal. So we need to draw another table. We need to draw another table. We need to draw another table. Because our table is not optimal. Now, for us to draw another table, we have said what you do, you take the highest positive, this one. So this one becomes the key column. That is the key column. This value here, D, which is at the title, tumesema it becomes the incoming variable. Incoming variable. It's called incoming variable. Then you take these values that are here and you divide the ratio. So 30 divided by minus 0.5 is negative 60. 75 divided by 0.75, it should be, let's 750 or 100. Show you 100. I am 90. We divide by negative 0.5. That is 180. Negative 180. Negative 180. Negative 180. So we are supposed to take I hope utaelewa hii lugha, the smallest absolute. The smallest absolute means we will ignore the negative signs here. So if you ignore the negative signs, the smallest positive absolute is that. So if that is the case, then this value here becomes the balancing figure. Because this one now will be called the key row. So this becomes the balancing figure. Sorry, not the balancing figure, the key element. That becomes the key element. And this value here at the title, it comes to be known as the outgoing variable. Outgoing variable.
Question, Mwalimu.
Yes.
Instead of, by virtue of you circling and drawing the arrow, can I be in a position to just circle and get to write it down, interpreting it, rather than drawing the arrows?
You actually even don't have to write the arrows. You actually even don't have to write. We expect when you are solving, these things are in your head. So you don't have to congest your diagram like I'm doing. But for me, because I'm teaching, I have to put everything so that when you go to revise, utajua why do we circle this, where did these values come from? And also it's a way of connecting you to what I'm doing here with what is already in your notes. But when you are solving, like now, kama ni mimi nilikuwa na solve peke yangu, I don't have to draw these things. I already know this is my key column because it's the highest. I know everything else. Is that okay?
Yes, it's okay.
Yeah, na si lazima uweke like where I'm putting. You can put them anywhere, or you are able to for your easy revision purposes. Okay. Now with that, we seek to proceed. We seek to proceed. And when we seek to proceed, we will draw So this is column C, and this one now is called third simplex table. Third simplex table. Third simplex table. Basis. Then we have space for K. B, L, 1, 2, 3, BI. So this is K, this is D, this is L, this is S1, this is S2, this is S3, this is BI. Then as you have said, you see this S1 now must be replaced by D. So we have D here, we have K, and we have S3. Then we have CJ, ZJ, and DJ. J. The contribution margins for D is 5, this is 6, this is 3. So what we do from there is this. We divide all these values by the key element. So we divide by 0.5. So 0 divided by minus 0.5 is 0. This is going to be 1. This is 0. This is going to be negative 2. This is going to be 1. This is 0. And this is negative 60. Negative 60. Aya.
A question, Mwalimu.
Yes.
Sorry, I came late. Where are you getting the C of the 560?
The 560. These are contribution margins. Contribution margin for D was 5. Contribution margin for K was 6. F3 is 0. The one is step 1. Kama ulipata tumelab formulation, that's where they are.
Okay.
Yeah. Aya, sasa let us get the workings. Let us get the workings for these other rows. The workings for these other rows. So as we have said, we even have them here. So the formula is odd row K value. Odd row K. We are looking for K. Odd row K value times new row value. New row value times balancing figure. Balancing figure is equal to new row K value. New row K value. Sasa, the odd row K, so I'll take 1 I have 0.75, 0.5, 0, 0.25, 0, and then 75. New row value, we bring these ones here. 0, 1, 0, -2, 1, 0, -60 times the balancing figure. So tumesema balancing figure is the value at the intersection of the key column here and the odd row that you're dealing with. So we are dealing with K. So 0.75. 0.75. So you take your calc and compute. So the first one will be 1 minus 0 times 0.75. That is 1. Higher. 0.75 minus 1 times 0.75. That is 0. 0.5 minus 0 times 0.75 is 0.5. I have 0 minus 2 times 0.75 is 1.5. 0.25 minus 1 times 0.75 is negative 0.5. 0 minus 0 times 0.75 is 0. 75 minus 60 times 0.75 is 120. We do the same now for row S3. So utakuja useme odd row S3. Hapa S3. So you bring the odd values. The new row, they remain. So the odd, it is 0 here. It is negative 0.5. We have 1, 0, negative 0.5, 1, and 90. And the balancing figure is the value at the intersection. Nice. It is this one, minus 0.5. So times minus 0.5. So we get those answers. So if you have used your calculator well, hapa umepata what? Hilo, si ndio? Minus 0.5 times minus 0.5 minus 1 times minus 0.5. 0 again. This is 1. Minus 0.5 minus 1 times minus 0.5. 0. This is 1. Kuna mahali nimekosea. Kuna mahali nimekosea. Let me start from the reverse. 19 minus minus 16 times minus 0.5. This is 60. Halafu 1 minus 0 times minus 0.5. This is 1. Then minus 0.5 minus 1 times minus 0.5, 0. And this one is 0 minus minus 2 times minus 0.5. It's negative 1. In the form negative 1. I'm right. So if I'm right, this is 6, this is 5, this is 2, 0, 0, 0, and 0. So we need to get the Z's. Now in the Z's, Z1, it will be 5 times 0 plus 6 times 1 plus 0 times 0. We are taking these values in column C, multiplied by the corresponding values here. Z2 will be 5 times 1 plus 6 times 0 plus 0 times 0. Z3 is 5 times 0 plus 6 times 0.5 plus 0 times 1. Z4 is 5 times minus 2 plus 6 times 1.5 plus 0 times minus 1. Z5 is 5 times 1 plus 6 times minus 0.5. 0 times 0. Z6, it is 5 times 0 plus 6 times 0 plus 0 times 1. Z7, it is 5 times minus 60 plus 6 times 120 plus 0 times 60. So 5 times 0 plus 6 times 1 plus 0 times 0 is 6. And when I subtract, that becomes 0. 5 times 1 plus 6 times 0 plus 0 times 0 is 5. When I subtract, that is 0. 5 times 0 plus 6 times 0.5 plus 0 times 1. That is 3. When I subtract, I get minus 1. 5 times minus 2 plus 6 times 1.5 plus 0 times minus 1. It's negative 1. Higher. 5 times 1 plus 6 times 0.5 plus 0 times 0 is 2. So this one, when I subtract, is 1. This is minus 2. And then 5 times 0 plus 6 times 0 plus 0 times 1 is 0. So I get 0. Then 5 times minus 60 plus 6 times 120 plus 0 times 60 is 420. So we minus. So we are not yet, because you can see there is another one here. Is that one that is positive. So we are supposed to go through the same procedure. We do a fourth table. We do a fourth table. But because of the interest of time, and because you already have the solution there, I don't want to do the fourth table. I think those two tables, they already illustrate the concept. So we are supposed to do the fourth table, and this is how it will be. So because we have it there, we are not going to draw it. I mean, to do the workings. But let us draw it. Just now we copy what is there and show you, so that we avoid those workings again. Possibly now I give you an assignment, or we do another one. I think the concept is already illustrated.
A question, Mwalimu.
Yes.
How comes we didn't come up with the column for ratio?
Because I don't want to do the next table. The ratio comes in when you are doing another table.
Okay.
Yes, that's when you need the ratio. But because of the interest of time and the concept is already illustrated, and we also have the answer here, I want to take that advantage to save time. So let's draw another table. But after you have understood, if you want to confirm how they arrived at the fourth table, actually the examiner did not want the candidate to solve. The examiner did not want the candidate to solve. So 1, 2, 3, 4, 5, 6, 7. Okay. So I'm saying this is the fourth table, which is the final simplex table. The examiner did not want us to go through all this, the table 2, 3, because there would not have been enough time. So the examiner gave us the solution. So this is K, this is B, this is L, this is S1, this is S2, this is S3, and this is BI. BI is what the examiner there is calling the right hand values, the one that is right hand. So in his basis, he has not included column C. So he's talking of X1. X1 is our D, this one, this D. X2 is our K, this one, the second one. And S3 is this one. So the examiner, badala ya kutumia D na K, yeye alitumia X1, X2, X3. As you can see them there. So the contribution margin here for D, we know it's 5. This one we know is 6. This one we know is 0. So the values that we finally got are 1, 0, 1 out of 5, 3 out of 5, negative 1 out of 5, 0, and 48. Then 0, 1, 3 out of 5, negative 1 out of 5, 2 out of 5, 0, and 84. I have 0, 0, 1, negative 1, 0, 1, 60. Now the CJ and ZJ, the examiner has, instead of using ZJ, DJ has used ZJ, so DJ. So this is 6, 5, 3, 0, 0, 0, 0. Okay, I don't know why the values are different kidogo. So let's just copy his values for the Z. This is 0, this is 0, this is a 5, this is 13 out of 5. This is 0. No, there is 4 out of 5. 4 out of 5, 0, and 7, 0, 8. So what happens then? Especially when you solve using a computer, when you use a software, the software may not give you these CJ and ZJ. They just give you the result. Because we know that DJ is CJ minus ZJ. So the software just gives you these results. And most of the softwares, instead of using DJ, they use Z. The other thing that you notice is for the computer, it produces all these as positives instead of negative. It's only that in your new syllabus, they don't require us to teach you these computer printouts, how to use the computer to solve and how to interpret the printouts. Maybe if you do another course in operations research, you'll come across that. But for now, I'm only supposed to show you how to solve. Yeah, and maybe to interpret a bit of the solution. So if that is okay.
A question, Mwalimu.
Yes.
And DJ for S1, how comes it's 13/5? Why not converting it to a decimal?
You can. I'm only copying exactly the way they have given here.
Okay.
Yes. But you can see in our workings we had converted. So either way works. Either way works. Haya, sasa we now need to interpret. And I'm only going to interpret two things which are in your syllabus. Whoever had set the question went a little bit beyond what we are supposed to teach you in the new syllabus. So once you have the table here, you now come and tell us the optimal production. I actually now do not need this one. Let me remove it so that I don't struggle with the space when I have a lot here, which I do not need. Sasa hapa unakuja unatuambia optimal solution. So in the optimal solution, I told you you give us two things. You give us two things. The first thing is production. So production, we have a product that was called standard. And if you remember, standard was represented by K. We had another one known as deluxe, which was represented by D. We had another one known as luxury, which was represented by L. So what you do here, nakuja hapa kwa basis, naangalia whether these ones are there. K is here. Unakimbia huko mwisho. What is there? Those are the units for K. So 84 units. D is there. Unakimbia huko 48 units. But L is not there. So if L is not there, it means there are 0 units. If L is not there, it means there are 0. Then we have the profit. And profit will deal with the maximum. And the maximum is Kenya shillings. Hii value ya mwisho hapa. Hii ndio profit. 708. So that is all that we can be able to answer. Any question? I would like you to attempt this one of September 2021. September 2021. Question 2B. Get the formulation and draw the initial simplex table. You will do the whole of it mpaka mwisho, but for now, because naona time imesonga, I want you to give me the formulation. I will want you to stop at the third table. The third table, most likely it will be optimal. Any question they have told you to use simplex, who are high PT for CPA, who are high PT, the third table. So hii yetu ilikuwa inapita sababu the examiner had not even asked us to solve. He only wanted the initial simplex table. So chora hiyo nikuje nione. Either. Have you been able to say objective function is to maximize Z, which is 3000. Umetumia leta gani? Oh, you have done nothing. So you can use A or we can use X for alkane plus 2001 for the second product. But you could use any other initial. So kama umetumia zingine, don't change. Subject to 2x plus 3y is less than or equal to 200. That is for the assembly. 4x plus 2y is less than or equal to 200. 5x plus 3y greater than or equal to 400. X and y is greater than or equal to 6. Changing inequality, the second step. Changing inequalities. So if you have said that, then you tell me maximize Z is equal to 3000x plus 2000y plus 0x1 plus 0x2 plus 0x3. Because you have 3 resources, so each of them has an S. Subject to, this was objective function. So subject to 2x plus 3y plus S1 is equals to 200. 4x plus 2y plus S2 is equals to 200. 5x plus 3y plus S3 is equals to 400. Then from there, you do the initial simplex table. So you can do that and proceed. Then, in case of any trouble, you let me know. I'm going to send you the notes for the next agenda. Last time I sent you a video for the solution. I hope you checked. So this one, I don't think I'll say. You just pabana and then give me the answer. If you give me the answer, I will send you the solution. Okay, so thank you so much.